All right. It's time to talk about Jank, everybody. Before I even do introductions, which is what usually comes first, I want to actually teach you the word Jank. Jank spotting, right? We all should do it, and that's the first part of this talk. So if you go to HTML5 Rocks, hopefully everybody has done this, it's a great resource, and you scroll up and down in an article, sometimes it janks. And especially on bigger screens or slower computers, it feels yucky. Now, let's define yucky. Watch the scroll bar as I scroll. See how it jumps? Or watch on your own computer, scroll up and down. That's jank. It's the screen not updating in some way. So, the purpose of our talk today is to get you so that when you walk out the door, you can make your site, or HTML5 Rocks, take your pick, so that when I do the same thing, no jank, right? This is our goal. I hope we succeed at it. The reason that we're up here is we work on Jank all the time. I'm Nat Duca. I'm on the Chrome developer team. I work on the rendering engine for Chrome, GPU, 60 frames a second, blah, blah, blah. Joining me,
I'm Tom Wiltzius. I'm the product manager on the Chrome graphics team, thinking about all the same stuff.
So we care a lot about this, and we want you to as well. So a nice, smooth web app is about feeding your display. So you've got many displays surrounding you. These are displays. There's a lot of variety, as it turns out. For various reasons, for budget reasons, for power reasons, different screens update at different rates. Now, what is this update thing? So you've heard the word vsync thrown around over the course of I/O a few times. And what this is that your screen is going to pull into memory somewhere and just pull out a picture from the GPU or from whatever and put it up on either the LCD or the CRT. And it's going to do that at a fixed heartbeat. You can't control it, especially not from software. It's just going to do that. Now, this is mostly a good thing. And being smooth, having a smooth animation, something that slides across the screen and looks really, really nice and buttery, is about having your picture ready when that happens, just before it happens. And you have to do so being aware of the fact that different screens are going to do that at different rates. So in the yesteryear, and even up to last year, some of the best JavaScript libraries out there animated with set timeout. jQuery, for instance, I think had an 8 millisecond set timeout thing. And we're here today to say,
don't do it.
Please, don't do it. Now, it's kind of complicated why you shouldn't do it. So we built a little simulation here for you to help you understand this. So what you're seeing here is a couple sliders. This determines my refresh rate of the screen. So if I'm a low-power Chromebook that's unplugged and decided that it should go in low-power mode, it's at 50 hertz. And the blue line means in time, it's going to update the screen at that point. So let's bring that back up to 60 for a minute. So then we've got our set timeout, right, the old-school animation approach. And that's at 16. So here's the thing. There's our set timeout. It fires. Then it fires again exactly 16 milliseconds later. And then again, so on and so forth. Now see the relationship between the timer firing and the blue line? It's moving. And in fact, you see this arrow, which is showing when whatever you did in that set timeout, the arrow draws a line to where the monitor, which refresh of that monitor is going to pick up your picture. So if each one of those timeouts moves something to the left by 1 pixel, you're going to get a picture showing up when the vsync line runs. Now here's the problem. 16 into 60 hertz does not equally go, right? 16 milliseconds and 16.6 are the two numbers that really, 16.6 repeating are your two magic numbers, and that's only for a 60 hertz display. The problem here, there are really two. The first problem is that as you go on in time, I'm just scrolling to the right to show you more and more of these patterns. Sometimes you get a situation where the same 16 millisecond timeout fires twice in the same v-blank interval, these two lines. And so this red X'd one never made it on the screen. So that's going to be an apparent jank, okay? You won't see that, and so all of a sudden, just for one fraction of a second, you'll feel like, oh, something's wrong. Mm-hmm. The other problem is that these lines are varying in angle. Now what that means is if you're moving something at a constant speed, say just trying to move something smoothly across the screen, the steeper the line, the more the velocity, the apparent velocity of your image will match what you're computing. But the more slanted the line, the more it'll appear to your eyes to slow down. And so in this case, if I just moved something slowly across the screen, you would, at a very, very subtle level, feel like the object was slowing down, and then suddenly would skip, and then it would slow down, but it would be very, very minor. So this is not buttery smooth.
No, we even call it sometimes like an uncanny valley of smoothness, right? You may be thinking, in a 60 hertz setup, does it really matter so much if I drop one frame in 50? Like, I'm not going to drop the 50th frame. And the answer is yes, it does. Like, you'll notice these things, but it's more, as Nat's saying, a feel, right? So this is the kind of thing that we can become very attuned to. And if you start to notice it, you're going to see these tiny little hitches.
So, and tweaking the number just doesn't make it better. You can turn it to 10. It just drops more frames. You're going to get more jank. If you turn it up to 17, because, hey, 17 is closer to 16.6, you'll get the same thing. It's just going to take longer for that to happen. And if you want to pass 16.6, the browser is going to drop that decimal part on the floor and give you 16 anyway. So don't use set timeout. We're sort of beating this point because there's been some discussion in the world about whether this is a good thing. So what should you do? Well, stay on time every time by using request animation frame. It's a drop-in replacement for set timeout. The quality of the implementation of request animation frame is not 100% on all browsers right now. Some browsers are still working, including Chrome, on getting little nitty-gritty corner cases just perfect. But unlike set timeout, which is sort of permanently messed up, we have a hope as Chrome or Mozilla or any of these to make it better. So please do use it. And the reason is because then when you're on a high-speed monitor or a low-power screen, your wrap is always on time.
And this is supported in all the major browsers at this point. Like, this is very much the direction everyone's going.
But this is not the only thing that you need to do to be jank-free, right? Because otherwise you could all just leave and go get drunk or something. But anyway, so we can't do that. We have to also keep in budget. So let's talk about budget. So what I have here is a request animation frame script that's just rotating this thing, right? Pretty straightforward. And what I've also done is I've graphed, just with the canvas, the time that I'm getting between these request animation frames. And you can see they're nice and regular, right? There's a good line here. Now this big jank button, right? It's a big red button. Don't press it. But if you press it, it puts a big sleep. Just puts V8 to sleep for a while. What happens is there are two things to watch. You'll see the spike on the graph, right? But also look at the actual spinner. See how it's sort of jumping, right? So this isn't terribly surprising. But this visualization of seeing this graph spike is incredibly useful. And it's so useful that we've actually built it right into DevTools. So new feature announcement, or you've seen it maybe. This is Chrome DevTools frame mode. And it's recording right now. And what we're seeing is that same graph, right, of the time between frames, live, plotted up top. And so when you see a long frame, well, let's try it out, right? Let's go here. I'm going to start a new recording. I'm going to press the big jank button, right? Go back. So now that nice, beautiful, flat thing that we saw now has these nasty things in it, right? Your eyes should be drawn to that because that's jank. So if I zoom in on this, right, if I click on one of these, one of the cool things you're seeing is these are good frames. These individual columns are nice, smooth, 16 millisecond frames. 16, 17, it'll be a little bit noisy. But this one, that one's right out, right? Tom, is 100 millisecond frame smooth?
Nope.
Right, so he's good. He's a good PM. So this is the jank that we introduced. And in fact, DevTools is awesome. We can go to here, see that big timer fired event, and we can see, oh, that's the big jank button, right? Now, it's not just about avoiding the big timeouts in your code. Like, you could just write a memo and say, don't sleep for 100 milliseconds. Okay, now your web page is jank-free. But not quite. So the other part of this puzzle is sticking within your budget. So I've got two buttons here. This early button. And as you can see, there's a little bit of noise, but that's not me clicking the button. I'm pressing this button really hard, and the frame graph is pretty stable, right? And then I'm going to do the same thing, and now I've got this 8 milliseconds late thing. And you can see we're getting regular jumps. Now, let's go back to the recording. I had a recording going. So here are the ones when I pressed early, okay? See how the line here didn't go up? What this is saying to me is that I used some time during my frame to do JavaScript, but I didn't push out my frame. Now let's look at this down in the bottom bit. So if I scroll down, I have to sort of find it. The recording's a little long, so bear with me. There it is. So here's our 8 millisecond fired call, and we fit it in between these two frames. See how it just fit right in? So because it just fit right in, it didn't push out the frame. But if I go over here and look at this one, so there's one of those timers that actually fired. And you can, even without zooming in too far on it, you can see that basically we started too late. And so we pushed out the frame, and this frame ran long. This frame is 21 milliseconds, right, instead of the 16. So this would have janked. And in fact, if you sit there in these slides and really pound on the 8 milliseconds late button, just hitting it, you'll start seeing the spinner feel a little bit janky. So the rule here is you've got 16 milliseconds to do everything, including all the stuff that Chrome needs to do to put the picture on the screen. If you're going to do work, you've got to stay in that budget, and you've got to measure it in order to verify that you're staying in the budget. So that's a nice toy example. It's one type of example. But what do we do in the web browser most of the time, right? We scroll. Like almost all of my web browsing time is scrolling. So you can get jank there too, and in fact we showed it once. Here's a toy example, number 2, of jank scrolling. So this code moves these divs around in an on-scroll handler, okay? It's a pretty straightforward example. It's not exactly the prettiest thing in the world, but we want to show you 2 things. First, I want to make you very, very comfortable with when you see this kind of pattern, just pop into the timeline and take a recording. So let's do that. Up and down. We're having some fun here. Hopefully we're having some fun. There it is. So here are some frames. So the first thing that should stand out to you is look at the size of these things, right? Again, back to Jank expert. Are these fast?
Only on a 5 hertz screen.
Right. So these are long frames. This is not okay. So we need to make this okayer. Technical term alert, okayer. So what I'm seeing here between these 2 lines, just pick any pair of lines, I'm seeing some green, which is painting, and I'm seeing some event. If I expand this out, you see just tons and tons of stuff happening in this event. So what I think when I see this is I go, well, let's hit this. This is pretty obvious, or maybe it's obvious. So when we pop into the source code for this, what the Chrome DevTools is pointing us at is this line. So what this is doing is it's trying to pull up, the test is just trying to pull up the scroll top in order to then use it in a formula, right? Now, one of the key parts of most web browsers is that when you ask for layout information or style, and scroll top is part of that, it has to recalculate the world, essentially, or a lot of the world. And in this case, that means figuring out all the div positions and everything and doing a big think, and then it'll give you back the scroll top. Now, then we take the value that we've computed and we shove it into this left position of our item, which goes and tells the browser, hey, the world has changed again. If you get asked about the world state again, recompute again. And so what's happening here is that we compute style, we dirty style, we go around the loop again, and we do this over and over and over again. And this is why we're seeing so many purple entries in the timeline. So, of course, this being a demo, I've made that behind a checkbox, right? So in theory, this should be faster now, right? But don't believe it, trace it, or record it. So I've got a recording going, and we're going to scroll again. Oh, happy day, it's gone. But hey, Tom, is that fast yet?
Still not fast enough.
So it's not smooth yet, right? I need a light that's, are we smooth yet? So now our paint is a problem, right? And we've got to hit this too. So painting, what's painting? So painting is the part where we take the styles that you've given us and we do the drawing. So line 2, fill, draw image, do a blur, right? All of that stuff, and it takes time. So when you see big paintings, start looking at things that could be costly, So when I look at this doc and I look in the elements inspector, well, the only thing up here really is a bunch of images. So it's a pretty easy case. But we look at these images and we've just got tons of styles on them. We've got, you know, background image, we've got a box shadow, you know. Let's remove that. So I've got a heavy painting class that this is all in. And so if I toggle that off like that, and we hit record again, this should be better. And in fact, because of a bug in DevTools, it's not completely smooth, but if you look at the actual costs, remember our paint time was, what was it, like 40-something?
Mm-hmm.
And so it's gone from 40-something to about 4 milliseconds. So definitely those CSS styles that I toggled off are to blame. And in fact, when DevTools is off, this is nice and smooth. So we busted some jank in some synthetic demos. Kind of cool, but you know, in general, what we're trying to teach you is keep your eye open for costly things, long frames. Anything bigger than 16 is right out. You've got to bust it. Garbage collection can do this to you. Just manipulating lots of DOM, heavy script, obviously. Timers are particularly something you have to be careful of. Be aware of a timer that comes in just about at the end of the frame, because it can push out that frame. Same goes for XHR. Use the DevTools features in order to bust this stuff up and make your website smoother. But there's more, and Tom's going to tell you about it.
Thanks, Nat. So Nat's been talking a lot about sort of what JavaScript, et cetera, can get in the way of your animations running smoothly. And there's sort of an implied limitation to what the browser can do in everything that Nat's just said. And that's that, why can't some of this happen at the same time? It doesn't really seem like there should be anything related between handling some XHR callback in JavaScript and the browser painting, right? Like, you might not actually be touching the DOM at all. But unfortunately, for better or worse, the way browsers are today, it's a pretty good assumption that everything happening in a given tab happens on one thread, i.e., that XHR callback can block painting, right? Also, that XHR callback could block your request animation frame from running. So if you remember, we've got this request animation frame that's ticking at the vsync heartbeat, but it can't run if some heavy block of JavaScript is running. This is a pretty severe limitation, right? Because this means that you can't really be running an animation at a time when you've got to do more than 16 milliseconds of JavaScript work at a time. Either you've got to break up your JavaScript into really little bite-sized increments and handle them in the RAF callback, or you can use CSS animation. CSS animation is one of the few exceptions to the everything happens on one thread rule. We brought this to Chrome for Android first, so we're going to do a demo on Android in a second. But pretty soon this is going to be everywhere, including on desktop Chrome. So let's switch to the demo here. I'm going to turn on the projector over on the left, and Nat's going to open up the source on my right. So if I look at this simple demo, this should look familiar. This is the same thing that we saw earlier. And what Nat was showing earlier as this logo spun around was driven by request animation frame. This is driven by CSS animation. And you can see that I mentioned this is only on Chrome for Android now, so for comparison's sake, if Nat hits the sleep button, you can see that little bit of jank happening, right? Like that little hitch in the animation, that's the kind of thing you want to be attuned to. Whereas if I hit that same button on this, JavaScript still just spins for 180 milliseconds, but the animation is smooth, right? This is huge. This is a big deal because it means that you can run arbitrary JavaScript and the CSS animations are all going to run. It's kind of like the easy mode of getting your animations to run smoothly because you just needed to define an animation in CSS, which is fairly natural for most web authors anyway, and then let Chrome do the rest. So this applies to both CSS transitions and CSS keyframe animations. And like request animation frame, you get some stuff for free. You get a lot of benefits. You get better timed, smoother looking animations, which is what we just showed you. But you also get better battery life because we can pause animations that are in background tabs. You get more graceful degradation because if there are a lot of things animating on the screen, we can drop the browser's refresh rate to 30 hertz instead of 60, for instance, and keep it regular rather than almost making 60 but missing frames every once in a while. Because for all the reasons we were talking about earlier, missing that frame every once in a while is what your eye notices, right? So it's much better to be very, very regular but a bit slower than it is to be variable and almost good enough. And this is the kind of thing that the browser can handle for you. CSS animations are particularly good if you're doing some sort of continuous animation like this silly Chrome logo spinning. If you've got some logo like that, and you want to be doing anything on your page, like all of your social widgets are firing timers all the time, for instance, this is going to get in the way of something like a request animation frame driven animation, but it will not get in the way of a CSS animation. It's also good for UI substitution effects. So you can imagine whatever Gmail wants to sort of nicely animate the opening of their compose window. They can do that with CSS animations, and it's much easier to do all the heavy lifting in the background of building up document fragments and doing DOM manipulation and parsing the email text, all the stuff that you've got to do to make your app run that you don't want to have to think about in the same way that you're thinking about the animation running.
Yeah, so we can't underscore this enough, right? CSS animation is your get-out-of-jail-free card. When you have something, you can't keep it to your 16 millisecond budget. Break out of that 16 millisecond jail temporarily by throwing up a nice animation.
Yeah, that's right. I also want to, before we go further, I should note that we talk a lot about 16 milliseconds because that's about right, but all this stuff about browser and screen refresh rates still apply. And I want to point out that just because you're within budget on your computer doesn't necessarily mean you're going to be within budget on most people's computers, which are probably slower than your computers. And it doesn't mean you're going to be within budget on phone and tablets and all of this stuff. So all of this is very, very machine dependent, right? So you need to be diligent about doing the kind of measurements we're talking about throughout this talk to make sure that you're actually comfortably within budget and can even withstand some variation in machine speed. So now we're going to go back to the demo we opened with, and we're going to try to fix this up. We're going to sort of show you the process that we went through to speed up this page. On this projector's resolution, the results aren't quite as dramatic, but you should still be able to see them, especially if, as I'm imploring, you use DevTools and actually really note the times. So I'm going to pop up DevTools here, and I'm going to look around. And I'm going to take a timeline recording of this page that we say scrolls jankily. And if I zoom in on some of those frames, what do I see? I see big swaths of green, right? I see all of this paint time, which is completely blowing the frame budget. These frames are 45 plus milliseconds long. And they're dominated. I mean, they're not dominated. The only thing going on is painting, right? So before we were talking about JavaScript getting in the way, the sort of complicated interaction between the browser painting and JavaScript running and style recalculation. None of that is going on here. This is a static web page, right? This is not complicated in the slightest, but it still scrolls really slowly, and it scrolls slowly on this fancy MacBook Pro, right? So you can imagine how well this scrolls on most people's computers, which are not nearly as fast, right? So what do we do? How do you diagnose those big, pretty opaque green paint blocks? When you're diagnosing a long paint time, there are a few basic questions that you want to start with. What element was slow, or what element is causing you to be slow? And what styles are causing you to be slow? The way we answer the first question is that we do this really dumb thing where we just turn off parts of the DOM, right? We just get rid of elements and say, did getting rid of this element improve my paint times? And then maybe we decide we don't need that, or we're going to do some sort of visual rejiggering, so it's not as big of a problem, et cetera. So we can start with something like that here. Again, I'm going to switch to DevTools, pop open the Elements view, and I'm going to start just looking for things to turn off. So I'm going to start with trying to turn off this header, because I'm sort of suspicious that it's on the screen all the time, and I'm just going to flip this to display none. And this feels a little smoother to my finger on the trackpad, but it's hard to tell that from the audience. So again, be diligent, take a recording. We switch back to timeline, we take a recording. Did we get better? We got a little bit better. There were some that were above 45 seconds before, so I maybe would count this a win, but it's not that significant, right? Plus, there's a downside here. I just got rid of the header. This is pretty integral to my site, right?
You can do it, and you can go push this, right? And sometimes that sort of thing will be a real hit. It's not unsurprising that we'll see websites that just lose 90% of their speed to one element. Mm-hmm. But in this case, it's sort of marginal, and it's kind of cool. I like that orange thing.
Right.
So we should keep it,
Right.
right?
So
Yeah.
we're gonna try not to make our UI designers, et cetera, angry, and by telling them that their layout is too complicated. And instead, we're gonna move on to the second question, which is, well, we're stuck painting everything that we're gonna paint, and we're not gonna worry about why it's being painted. Instead, we're just gonna say, what made this take so long? Like, given that we can't change it. And the answer is always gonna be CSS styles, right? CSS styles define what the page looks like. It defines what an element looks like. It also defines how an element renders, right? So when we tell an element to go draw itself, we being like WebKit, right? The amount of time that that takes is highly variable depending on CSS styles. We wish it was the case that all CSS styles sort of took equal cost to paint, because it would make
I want a pony as well.
Yeah,
Like,
right. It would make performance optimization
Yeah.
much easier, but it's just not true, right? And so much as Nat's saying earlier that sometimes one element can really slow you down, similarly, sometimes just one or two styles, or like the intersection of a couple, can really, really kill you when it comes to paint times. So we're gonna start doing the same dumb trick, right? We're just gonna start turning stuff off and seeing if we can identify a couple things that are really causing us pain. So again, I'm gonna flip open DevTools, go to the Elements view, and I'm gonna start poking around. The first thing I'm gonna look at is maybe this background. It's on a lot of the screen. Like, the reason I'm choosing this is because it looks kind of complicated, especially if I inspect it here. Like, there's all this like 20 lines of CSS declaration for this thing, and it's all over the place, so I'm assuming maybe it's going to take some time.
Well, and even more amusingly, on your projectors, it's showing up as gray. But when you look at it here, it's got this nice little checkerboardy thing, and it's all gorgeous and textured.
Yeah, I apologize.
But you're not going to see it. And maybe we're paying a lot for that.
Right.
Look at all that CSS.
Right. So we're going to go back to the timeline view again. Oops. We're going to take a recording. We're going to scroll down. We're going to see what changed. A lot changed, right? So now I've turned off that background, and my frame times are now like in the high 20s.
Tom, I think we classify that as a win.
Yeah, right. This is like
Pretty brushed metal aside, right?
Right, right. But again, there's this trade-off between the visual effect you've achieved with the styles that you've used and what they're costing you. And so this process, this is only the beginning. As we disable things, and I'm going to disable something else too. As we disable things, like, we're making the page look different. So this is only the beginning. The next step is adding stuff back in, or trying to achieve the same visual effect via different styles that won't have the same sort of like pathologically bad cost. So in this case, there's one more thing I want to try. Thanks to Nat's demo earlier, I'm thinking maybe like box shadows are a bad idea, so I'm going to go turn off box shadows and maybe the backgrounds of these things too, for the same reason that I turned it off on the body. And looking at this, it feels a lot smoother to my finger, but once again, not going to trust it. I'm going to go to timeline, take a recording, and like, wow, that just got way better, right? There's one big one at the beginning. But almost all of these times, like, look how low these are. We started off at like, what was it?
Jank-tastic.
Like 50 milliseconds a
was
frame or
some big
something,
number, right?
Like, i.e. 5 frames worth in one frame. And now these paint times, they're like so small, I'm having trouble clicking on them. They're in the like few millisecond range, like 1 millisecond range. And again, you're saying, well, that's great, but you changed the way the page looks, right? And that's totally fair.
So, I mean, and this is PM versus programmer. So I'm going. Like,
Right.
I'm good with this, right?
Right.
But this creates the right tension, right, between design and technical that you can then use.
And even at a technical level, again, like you can then start building your way back up. Now that you've identified what's causing you problems, because again, I didn't change that much here, right? I got rid of the box shadow and the background, and that's it. And like that completely removed the problem. So the question is, how do I get that nice background gradient, and how do I get that nice drop shadow effect, but without all the paint time cost? So I have this version. Oops, I'm gonna leave that open for later. I have this version that I fixed up a little bit, and I did it exactly what I just showed you. I just started hunting around for stuff. I went straight for the ones I found eventually first in the interest of time, so you didn't have to sit through anything too boring, but like you can imagine how this process goes, right? And then I built it back up so that it visually looks almost the same. I did this quickly, so there are a few differences, but you can imagine getting there, right? And I just used images. I honestly just took screenshots of the background and like tiled them, and that was way faster. So now you can see that like this thing is zippy, and if I open up DevTools, switch to timeline, take a recording, like we're not at the 1 millisecond paint times that we were before, but what are these costing? 3 milliseconds?
Yeah, that's butter.
It's an order of magnitude faster than it was before, and it looks the same, right? Like this is significant, and all I did was change 2 styles. So the point is, sometimes and this was like a live website, right? Like this is a live website that Google made. So the point is, there are plenty of times when just changing a few little things is going to have a huge impact. But the hard part is, how do you find those things? And that's what we're trying to impart today, right? We're trying to explain to you the process and the tools that you can use to identify those bad cases. There is one more trick I pulled in between the good version and the bad version, which I'm going to open back up again. And the way I found this trick, the way I found this thing that was additionally slowing me down, was through about tracing. So DevTools is great, and we recommend everyone start with DevTools, and the new features in Timeline are particularly compelling for this. But if this is not enough for you, you can get a lot closer to the metal by using about tracing, which is a special tab in Chrome. It's what we use to debug performance problems in the web browser. And it can be really useful for you if Timeline isn't enough for you or if you're just stuck. And it'll show you a lot of stuff that's happening inside the browser. It exposes Chrome's multi-process model. It is a lot more complicated and not nearly as user-friendly, but there is some documentation that the 2 of us wrote up. We put it up on the Chromium dev site, so you can check that out from there. The trick that I discovered for this particular page using about tracing is something that doesn't show up inside of DevTools right now, and that's image decode costs. So as I mentioned earlier, that green paint block that we see in the DevTools timeline, today it's totally opaque, right? You don't get any granularity into like what is the web browser doing. We're working on that, and so those of you who saw Pavel's talk before with Sam, you guys know that there is some good stuff coming from DevTools that's going to expose more detailed information. But in the meantime, like that wasn't obvious to me from DevTools, but I saw these long JPEG like decodes and resizes, basically.
Yeah, I mean, what happens is if he'll show you the trick in a minute, or maybe you can bring up the bit. You'd scroll. It felt really good, but the first time you loaded it, just the first time, every once in a while you'd see something and you'd be like, what the heck was that? That felt a little janky.
Right.
And it was in the uncanny valley territory. This page started off as really just terrible, right? But there was still this uncanny valley, and it was showing up as long paints, but you couldn't tell why. So that's where you jump into, if you care, you jump into tracing to figure that last bit out.
Yeah, and so in this case, again, there were some JPEG decodes that were showing up. These can take upwards of like 40 to 60 milliseconds, even on this fast computer. And so like this is huge, right? Because again, that happens within a frame, because the web browser is not doing anything else while it's decoding that image, at least in the renderer, right? Which means that you just missed 5 frames. Like you just stalled. You're done. And this is bad. So how do you avoid this? Well, in this case, the reason that these scales were happening was because the images weren't sized at the resolution that they were being displayed, right? So DevTools will tell you this. It just doesn't show up as a component of the paint time. So if you mouse over this image in DevTools, you see that it is being displayed at 300 by 300 pixels, but in fact, it's a 512 by 512 pixel image. And again, like that JPEG scale probably doesn't seem like a big deal, but it starts to become a big deal when you start thinking about things on the order of milliseconds, right? Because a 40 millisecond image resizing operation actually becomes quite painful. So from the good version to the bad version that I was showing earlier, in addition to making those 2 style changes, I also resized all the images so that they were displaying natively. This is a simple trick like any of you can pull, because this has no visual impact, right? This is just a perf win.
But it will cause jank. Most websites I've been to, this is a really common one.
Yeah.
So Go to your websites now.
So this is just the kind of thing,
Fix it.
like,
Okay.
the point here, lest Nat get too emphatic, like, the point here is not, here are some magic bullets to go make your websites faster. The point is the process, right? This is all about the tools that you can use and the techniques that you can follow in order to figure out what's slowing down your site. Browsers evolve really fast, and like we're two of the people who are like trying to evolve the browser really fast, right?
To blame.
Right. So all the specifics of what we're talking about here, the drop shadows and the background gradients and the image resizing, like we're actually actively working on making all of that faster. So hopefully in 6 months, like they're not going to be a problem.
But then there'll be another style or
Exactly.
another new hotness, and that one will be tickling a corner case in the browser, and it'll make the browser sneeze. Or it'll be fast in IE or fast in Chrome.
Right.
It's this wild world out there.
Browser variation also huge, right? Like as we care more and more about performance on the web, like it starts to become a problem that like different browsers do things slightly differently, and et cetera, et cetera. So the point is use the tools. Like start to train your eye to notice jank. Follow the architectural best practices that we've laid out, because these are true across browsers and will be true across time too. Use request animation frame. Use CSS animation. Make sure you don't have like 1 second long parsing JavaScript operations going on during. Right. Or like, I mean, kick stuff to worker threads, right? Or like break stuff into queues and yields, right? Like anything you can do to not like clog the main thread with all the other crap your application's doing is good, right? But again, the specifics are all going to change. So once you start to notice jank, you're going to see it everywhere, and hopefully you've got a passion for making things faster. You want to make your site faster, et cetera, et cetera. So you're going to use the DevTools timeline. You're going to use about tracing. You're going to do this funny trick we did where we just start bisecting down what's slow by turning things off and re-enabling them. And with that, hopefully, you'll be better equipped than you were before to make this stuff fast. If you're hungry for more, these slides and other resources are up at jankfree.com. And we are actually going to we're going to take questions in a couple minutes, but we're also going to be at office hours in the Chrome area, just around the corner, I think, right after this talk. We like doing this. If you have a site that's janky and you want to come by, like, we'll take a crack at speeding it up. We'd love to do that like for an audience too. So if anyone wants to come by,
bring your puzzles.
Try that.
Yeah.
We'll give it a shot. And with that, I think we're going to say thanks and take questions. Anyone got anything?
I have one
Yeah, please.
The CSS animation transition threading, will that or does that apply to WebView?
You're talking about Android WebView?
Yeah.
Long-term, yes.
Long-term, yes?
Yeah. So, you know, the web moves really fast, and there are like a zillion different ports. But WebKit in particular, and CSS spec in general, the animation spec, it allows this. So it's good to design for. Even if it's not working today, it will start working everywhere within the next, you know.
But this is very much our plan.
The next soon. That's a unit of time.
Yeah, and like there is going to be other stuff like this. Like basically, we're trying to kind of move away from the model of everything happens on the single thread in the renderer, right? And this is kind of the beginning of that, but there will be more things like this as well. So, yeah. Please, yeah.
Hi. So one of the use cases between mobile browsers and desktop browsers is that on mobile browsers, people tend to zoom a lot, right? So, you know, what can you say about that and handling that? Like your image case, it's useless if it's only 300 by 300, but if you're actually zooming in, you can actually see that extra detail.
Yeah, so I would say, you might also say like for high resolution screens, like I want that image to be able to be resized at a larger resolution, right? Like there are a lot of cases where you're going to make trade-offs between like quality essentially and performance, right? Like these things are almost always going to be in tension. I think in that case, you're probably just going to have to decide where on that
You're totally right.
path you fall.
Mobile browsers are at the forefront of awesomeness in terms of like stuff behind the scenes.
Like perf wins because the hardware's weak, right?
So that will bite you in the case of a pinch zoom. But mobile browsers have, especially Chrome Android, has some very severe magic so that you wouldn't even notice this in the first place during a pinch zoom. we'll probably blog about the magic at some point. But essentially, when you use Chrome Android, you can time it, you can pinch zoom, and you'll actually see that in that case, you won't get a jank, and so then you won't care.
Yeah.
That's the best answer I can give you.
We can talk more about that at office hours. The full sort of magic explanation is really complicated.
I hate that,
but
But
we're happy to talk about it more.
Measure.
Yeah. Yeah.
Hi, great presentation. You hinted at some more tools that you're going to be adding to the frame view and the profiler. Can you give us some hints or some updates on what those are going to be?
Well, how about you tell us what you want?
Sure.
I'd love to be able to see the element that takes the longest and just be able to go right to it instead of having to display none.
That sounds cool. Yeah, we should totally do
you
that.
should tell that to Pavel.
Yeah. So to be clear, we're on the
Pavel's in the
GPU
back.
team, and we're pushing for a lot.
And we bug Pavel, who's sitting in the back and just talked about DevTools all the time for we totally want things
Maybe,
like this.
maybe line numbers and functions that take the longest time, which where you're spending the most time inside of JavaScript functions would be awesome.
No, well, so my hope, and my actual boss is in this room, so I hope to be able to stand here next year, and instead of having to say, oh, look at this big green thing, and then spend, how long did we spend? Like 20 minutes trying to explain what was slow about the big green
just
thing.
clicking stuff,
I'll
right?
push a button, and it'll be like that one.
Yeah.
That would be
That's-
great.
that
Whether
sounds
we can
awesome.
get there, yeah, TBD, but that would be a nice thing.
Definitely granularity in like paint costs is something we're looking at. I think like some of the JavaScript stuff may be better served by improving the profiler than improving timeline, right? But like it's a point well taken.
Great, thanks again.
Thanks, and feel free to file new.crbug.com.
That's right.
Because we really do read all that stuff. And so, like, crazy ideas are awesome because we can tell you you're crazy, but then we'll listen and make a note and we'll try to do it.
Yeah.
So this tracing and recording thing, are they really slow down the web page? So if I disable them, will the web page work faster?
In some cases, yeah. Like so, you even saw like Nat at some point during his demo was like, yeah, this still looks, even though I've disabled my heavy on scroll handler and my costly CSS styles, it's still a little janky. And as soon as you closed DevTools, it got a lot smoother. So there is some instrumentation overhead, especially with DevTools. That's going to be fixed. Pavel's going to fix that.
So the high level is, we're trying not to build things that have those corners, right? When you're using, this is bleeding edge, this stuff that we showed today. It's the,
like this is yesterday's canary.
this is like the canary. By the time this is stable, it'll be totally awesome, and you may hit a corner case, but it's very, very unlikely.
Yeah.
Does that answer your question?
And there should be like there is sufficient granularity in the timeline already that like we saw some problems where like there's some instrumentation overhead and you don't get the frame times you want, but we still know pretty well how long the paints take, for instance, and that kind of thing shouldn't be as dramatically affected by
Yeah,
tool
but I
overhead.
still cannot use it for stats, right?
What's that?
I still cannot use it for stats.
You can't maybe use it for, in that case, like frame time stats, but you can use it for like, if you cut your paint
Shouldn't be
time in
that
half,
intrusive.
you have cut your
I
paint
mean, I
time in
cannot
half.
say my page shouldn't run like 60 frames per second.
Yeah, you
Because-
can.
Well, I mean, you can see that within a frame you didn't take, like your page only consumed, whatever, like 10 milliseconds worth of stuff, right? And then if you close DevTools and it's fast, then you're good, right?
Right, but
It's good.
if it's recording, then
It's
then
not
it's
that,
not
it-
60.
it's not that heavy and it's not on that process. Especially, like, yes, on an Android, you might get a slight penalty, but to be totally honest, by the time we're done, it should be maybe 1 or 2% overhead, which 1 or 2% overhead on 16 milliseconds is non-zero, but it's not so much that I think it'll perturb the average web page enough that you'll notice.
All right.
Okay?
Yeah, thanks.
Awesome presentation, awesome tool.
Thanks.
Totally stoked that we have it. My question is, now we have high DPI devices, not necessarily Chrome. I mean,
Yeah,
you know,
sure,
it's like the iPhone. And so using background size, you need to use background size to take these huge images so that they're high DPI. And your example, so is there any way to measure it on, like, I know your tools only work for Chrome, but how can we force it into a high DPI without buying the new MacBook Pro that's higher DPI?
So,
Probably a question for Pavel, who
Yeah,
you can turn around and walk to.
well, I mean, I can give you some starter hints. One, there's a way to turn, if you got a non-high resolution MacBook, you can flip it, if you install some tools, you can flip it into like a fake high DPI mode. Won't be as accurate because you can't get the whole thing, so you can't get like the cost of full page repaints, for instance, because it's only a quarter of the screen. But at least you can see how things will look, and you can get a sense for some of the timing, which is a start. There are ways to avoid like using JavaScript and stuff. You can only load like, I think this was the first part of your question, like you can only load high resolution assets if you need them, kind of a thing. You can use media queries, for instance. So that'll sort of avoid unnecessarily taking the hit, and as for profiling what the hit is like, you can kind of, again, fake it, but to really test, yeah, you probably gotta buy a new
I do have one,
computer.
like, ignoring the image discussion, there is one caveat for all of you, which is high DPI means that your paint time's double. Not exactly, but that's your risk, right? You're painting twice, well, 4 times as much.
Yeah, sometimes it's
You up by 4.
quadruple. Yeah.
Look at me doing math.
Yeah. Yeah,
Yeah, no, this is me doing math in a really funny way.
right.
4 is the number.
No, like high
Yeah, I
DPI
shouldn't work for Google, should I?
Right.
So,
No, but like high DPI, the point is high DPI stuff is going to have significant
so you got
costs,
to keep your
especially
paints
on
low.
paints.
So if
Yeah.
you're like on this MacBook Pro, this is like a 2-year-old MacBook, and it's really chugging and it's hitting like 15 millisecond paints, then you're really, this is not going to work on one of the new ones because the paint's only going to go up. It might be a slightly faster Intel CPU,
It's not 4 times faster.
but you got to keep it small, right? And give yourself headroom for the higher end devices and the lower end.
Yeah, and I mentioned this a little, like really briefly as an aside during the presentation, but I do want to put a plug in too for like, most of you are web developers, most of you have very fast, very fancy computers. Like, think about the computers your users have, because they are not MacBook Pros, right? And like, we collect stats, like anonymous stats about like the common sort of like system configurations of Chrome users, and like, I'll tell you, like the average Chrome user has like a really crappy 3-year-old laptop, right? And like, this is what the internet population is. So for some things, this doesn't matter, but for like really sensitive performance stuff, like I'm trying to make a 16 millisecond paint frame budget, it's huge, right? So think about that. Like, I would even recommend maybe testing on not your development machine, for instance. But that's
So,
just me.
literally exactly on that point, and maybe this is for Pavel.
He's not a plant.
Okay. Can you guys just add a like make
Slow
my
me down
computer?
feature.
Yeah, exactly.
We've talked about it. It's a little hard to do super accurately. We've talked about like making it do something like, just like paint everything 10 times, right? Because that way even small paint time problems will be like really magnified and you'll really be able to see them. I think we probably need more fine-grained instrumentation before that's gonna be really useful.
That's geeky cool. We should
But-
figure out how to make something.
But it's
With your
a
intent
good
to
idea.
work.
Like, I think your intent is spot on.
I think your intent is really key. You want to be able to, from your computer, understand the performance of this content somewhere else. And that's hard right now. So maybe we should figure out, maybe as a community, how to do better there.
Yeah, I mean, just like,
Yeah.
you know, what Pavel was saying in the previous session, you know, the dev tools and the real time and all that kind of stuff, and, you know, having to right now have a bunch of VMs or a bunch of
Yeah.
like Chromebooks and these kinds of things, it just doesn't really scale versus if I have a slider in my dev tools that I can be like, okay, I want to run at,
Totally.
you
Slow
know,
down, yeah.
20%, see how this feels, oh, I can have all the same timeline, all these kinds of things.
Yeah.
Now the ability to improve my performance on, you know, substandard machines dramatically improves.
Totally hear you.
Yeah.
Thank you.
Thanks.
Take it.
Hi. I had 2 questions. So the first one was, so in the example you had with like drop shadow and gradient or something like that on HTML5 rocks, you said you replaced them with images to improve the performance, is that right?
Yeah.
But that's obviously not ideal from like a web development point of view, because we want to use semantics.
And like the spec people are going to kill me, right?
Yeah.
Like, I'm just like, I'm
So-
here saying like, oh, don't use any of this, it's not fast enough.
Right. So like, I mean, are there other techniques we can use now, or is there something browsers could do to optimize that more? Because like, I would assume that the browsers would, you know, pre-render shadows and cache them and not have to re-render them all the time.
Yeah, and there are things like that we're doing. And like, this is why we ended with like, don't listen to the specifics because they're going to change. And like,
Right.
the way, like, there are even bigger changes than that afoot in like Chrome's rendering pipeline to some extent. And there's going to be caching at like a much higher level where we like stuff on the GPU, so we don't need to repaint that anymore.
Yeah.
And like, yeah, that's all going to be happening. So like, it may end up being that the one-time cost of like rendering those shadows, say, it actually turns out to be pretty insignificant for you. And so I guess the short answer is yes, the browser is going to try to take care of this for you. I don't want you to sweat like drop shadow
Yeah.
too much. Like, this was very much a demo that was meant to show you like how to find something that is taking a disproportionate amount of time and then dealing with it right now, right? But I absolutely agree that the browser should be solving this problem, and we're trying.
All right. And the other quick question is, one of your slides you mentioned something like performance.webkit now, but I don't think you talked about it. I was just curious what that was.
Oh.
Yeah, we slipped that in there. You got a good eye. You can Google it. Date.now is how we've always measured time. And something that we slipped out there, and it's going to be in pretty much everywhere, including IE, is window.performance.now. There's this whole prefix game, right? But it gives you time at a sub-microsecond resolution. It gives you the fastest that your computer can give you. So now you can timestamp individual functions even and get reasonably good numbers out of it. Totally use it. We used it, but we didn't want to go into too much detail. But it's a pretty cool addition to the platform.
And it's very useful for things like this when you're thinking on approximately
millisecond is
milliseconds.
a 6% error. So
Exactly,
correct my
right.
math,
So
right?
it ends up being very important to have sub-millisecond precision, and so we're finally bringing that to the browser, which is good. And we're actually going to even change, for any of you who already knew about request animation frame and think oh, this is all old hat, we're actually changing the request animation frame specs slightly to use the new high resolution timer. So you get a timestamp with the RAF callback, and it used to be measured in milliseconds since the epoch. Now it's measured in whatever the high resolution timer is, which is since page load. So if you were using it already, check your sites.
Did you get the answer you're looking for?
Yeah.
Great.
Cool.
Thank you.
Cool, that was actually part of my question, so that you could get some metrics from the field with this kind of stuff, because it's nice as a developer, but if the device diversity is so huge, especially with the new GL stuff, because I'm trying to make UIs in GL now, in WebGL, and it's really cool to beat the 60 FPS one, but it's really terrible if you have to do it in Firefox as well, and all these other things that are different. So my question to you is, how do you see the 60 FPS domain with browser diversity? Because you guys are optimizing in ways that you have to adapt to get that 60 FPS, and everybody else is doing something
Well, actually,
else.
So in theory, let me game something out with you, and let's hear your feedback. Firefox is actually, at this minute, the Mozilla team is adjusting their RAF implementation to do a lot better. It used to be that their RAF implementation didn't actually hit 60, and they're changing it to actually hit 60 as we speak. So good content that does what we think the right thing is for the platform then drives the browser vendors to optimize or to make things work correctly. All of this stuff is so new that there's a lot of diversity in the correctness of the implementations.
Right.
So my theory, might be wrong, is that this will get a lot better in about a year as people really catch up in their implementation quality of the spec. I think the spec's about right, plus or minus some nasty details, but we need to really polish it.
Right. So
Is that responsive to your question?
well, I mean, you're optimizing, right? So you're profiling and optimizing, and that means that you get case-specific for browsers to try to make things faster. I'm just wondering how you see that evolve. Is that going to stay within the spec, or are people going to have to jump through hoops?
At a meta level, you're absolutely right that this is a problem for the ecosystem, right? The potential for performance profile divergence amongst the browser vendors is potentially very serious, right? And we actually have probably a lot more in common with Firefox than we do with, say, IE, but you want your stuff to work on IE too, and it's implemented very differently.
How is IE responding to the 60 FPS thing?
Oh, they've got request
IE
animation
is actually
frame.
super keen on performance now. They're super keen on performance and spec compliance, and they don't
And
maybe
they've got-
move as fast as we do because they don't want to drive things forward as quickly, but they were very supportive of request animation frame,
So
and this is
Let me be clear, at least to my
Something to care
understanding, there's a branch here. So there's the techniques like request animation frame and keeping within a budget. That applies to IE as well, especially IE that have request animation frame, which is, I believe, 9+.
I think it might be 10. but yeah.
I'm sorry. You always want to keep that 6. That's not a fact of a browser. That's a fact of these stupid display thingies that we love. The place where there is browser-to-browser divergence is which CSS effects get you in trouble, or which DOM
Or GL,
manipulations,
right. Yeah.
or to a certain extent
I mean,
GL.
GL's a
That's
little
usually
weirder,
just
but yeah.
because of GPUs.
Yeah.
So
I missed it, but is that gonna go into IE at some point? Or?
Ask them.
That's way
Ask
above
them.
my
Okay,
pay grade.
Yeah.
Well, I mean, if we're optimizing, we have to sort of look at what we're targeting, right?
Yeah, totally. I mean, it is my sincere hope that IE adopts WebGL. They're the only browser who hasn't so far. And I say this as the Chrome graphics PM though. So obviously that's what I want.
Well, same here,
it is,
but you know.
it is unclear what they're going to do in
Yeah.
the 3D on the web space. I think they will do something pretty soon is my suspicion. But what it is, they're pretty quiet.
Okay.
So, I don't know. Sorry.
Good stuff, guys.
Yeah, and feel free to reach out.
And we're happy to
if you have
talk
any
more about
questions.
that kind of thing afterwards. Any other questions? Otherwise, we'll wrap up.
Thank you, and we'll be out in the area where Chrome is if you want to bring us
Happy to
over a
talk,
slow
yeah.
website.
All right. Thanks.